The sequence Sn of real numbers given by Sn equal to define as this: a convergent sequence, a oscillatory sequence, not a Cauchy sequence, a Cauchy sequence. For options given to us, and we have to find right one option. As Sn is sine pi upon 2, 1 into 2 plus sine pi upon 2 square upon 2 into 3, and so on up to sine pi upon 2 raised to the power n divided by n into n plus 1. In denominator you can understand product of consecutive terms, two consecutive terms, and in the numerator sine pi upon 2 or pi upon 2 raised to the power n is given as. So this Sn is nothing but sequence of partial sum, as S1 S2 you can find. So as we study in series, this is sequence of directly partial sum is given. Sequence of partial, it means directly we can say this is sequence. So Sn can be written as summation sine pi upon 2 raised to the power n divided by n into n plus 1. This Sn can be written as like this, and we have to check it is convergent or not convergent Cauchy oscillatory sequence. So we are going to find limit to check it is convergent or not. Limit of Sn equal to limit of summation, and we know that limit over summation is same as summation of limit. So summation limit n tends to infinity sine pi upon 2 raised to the power n divided by n plus 1. We can write this way, in this way. And also we know that limit x tends to 0 sine x upon x is equal to 1. We will use this concept here. So make this numerator as in this format. So summation limit n tends to infinity sine pi upon 2 raised to the power n divided by pi 2 raised to the power n. This is divided by pi upon 2. So multiply is also pi upon 2 raised to the power n, and in denominator 1 upon n plus 1 is given. So the value of this one is 1. So it can be limit pi upon 2 raised to the power n into n plus 1. And as n tends to infinity, this one goes to infinity, and 1 upon infinity, this one entirely goes to 0. So limit of Sn is 0. Limit of Sn is 0. It means sequence of partial sum is convergent. So Sn is convergent sequence. Sn is convergent sequence, and we know that every convergent sequence is a Cauchy sequence. So which one option is true? Option A is wrong because of divergent is given. Oscillatory, this is again wrong, not a Cauchy sequence. A Cauchy sequence, this is true because this is convergent and every convergent sequence is Cauchy. So only option D is correct.